Hi everyone, and welcome back to the channel. In today's video, I'll show you how to extract comorbidity conditions. Like in this case, I'm working on HIV, which is human immunodeficiency virus, from National Ambulatory Medical Care Survey. So previously, we have done more videos on National Healthy Nutrition Survey. So in this, I'm going to focus on this NAMCS. Now, what you need to have, and I'm going to share these links, is just have this the link to the database and this ICD-10-data.com, this link. Now, this is useful if you are studying chronic disease preferences, maybe patient risk profiles or healthcare utilization trends. I know these surveys maybe across the internet, not all of them have maybe all the information that you may need or the kind of data that you may need. So it's good to know how to use to at least make use of the free source data surveys. And this data is in two types. So we have public use files and restricted data. So for those confidential, high confidential data, like especially in cancer, so they are under restricted data. And this one you have to follow the link and do all the necessary so that you can have access to that kind of data. So in my case here, we are just going to use this public use files, and I'm going to use the STATA data file. So I just click STATA data file to download it. Secondly, I'll open the code book. This code book shows the information that we have in that data. You can be able to see the variable name or the information all the way. But my main interest is this DX1 to DX30. Like in 2019, these conditions like HIV is being given direct, like you can be able to see yes, no. But this one is given in what you call ICD-10-CM diagnosis. So it's given in codes form. So you need to understand on how to handle this. So what you need to do is you come to this other site and you just search the condition that you are interested in. So like in my case, I'm interested on this HIV. I just click HIV. So I need the code. So I do that. And now I'll be able to have, if you look at this, I have ICD-10-CM diagnosis code. So it is P20. So this is what we need. After that, I'll go to my STATA. I'll go to my STATA so that I wrote now and explore the data, which is 2022. I've already downloaded that. I do that and I explore the data. So if I just click describe, that is it. So this is the data we have. We have 202 observations approximately and 75 variables. Now, if I click browse, I'll be able to see the data. I'll be able to browse here. I'll be able to see the DX1 to 30. It's given in codes. You can be able to see those ICD-CM codes. They are there. And all this -9, it means it's a missing data. If you go to that code book, you saw that basically this -9 is just a missing data. So we are going to get rid of that. Perfect. Now, next thing is we don't need all these 75 observations, so we need some few like demographic information variables like age, ethnicity, and so on. And all these DX1 to 30, we need them. So I'm going to filter the data like that. Then I'm going to drop the missing data. So we cannot use this kind of data with all this missing data. So I'm going to drop all that. Perfect. And now you see 281 observations have been approximately have been dropped and have remained with 619. And this means, so you don't need to worry about the sample size, because at the end of the day, we are going to use the population size or national represented data. So we are going to do some survey design set. Next step is I need now to, the next step is to now clear, is to create now the condition, so like the HIV. So I need to create a variable to flag those fists where the patients as HIV using the ICD-10-CM code. So let me create a flag variable, create a variable to flag. To flag is just actually going in and I'm a variable fist. So we're talking about fist where patients as HIV using the using ICD then CM code, then CM code. So I'm going to generate a variable. So generate HIV is equals to 0. So those that do not report the HIV. Now for each, so I'm going to use a loop function here. For each dx of variable list dx1, so I have to list all of them, dx30. Yeah, so open that, the loop function, then replace. So replace HIV is equals to 1. So those now with those that condition, if dx is actually equal to negative, so b 20. We saw that from the other side. Sorry, so negative 20, like that. So not the negative 20, p20. Then I have to close this loop function. Then I can repo the variable, but it's optional. Repo variable HIV. I label it as human immunodeficiency deficiency virus disease, like that. Then I now execute this, highlight and execute. Sorry, for each dx we have this has to replace by that. Then here we go. So the variable, error there. Sorry, good. Now we go. So we have generated the HIV data based on the ICD-10-CM code. So now if I can just have from this, like this loop, I can inject each diagnosis field, and if n of them equals to this p20, the HIV variable is set to 1. This means the first includes a diagnosis of HIV, human immunodeficiency virus disease. Next, I can summarize the result like just a simple summary start. So I can just say tap HIV. I got that. So I'll be able to see yes, no. So for all those fields, so 8 of them reported the condition that they have the condition. 611 reported they do not have the condition. Now the last step, once you have all the information you want, like the chronic conditions that you want or comorbidity conditions, then you can be able to set your data. You don't forget about this. Do the survey design, and if you need more help on this, please consider to watch my previous videos. You'll be able to understand this, what I mean by survey design set, because we need to nationally represent this data. So that's why I was saying you don't need to worry about the sample size. Even if we have a sample size of 100, we can now do that. We can do the national representative of that 100 sample size. So what I need to do is I need to say survey set, survey SVY set, then sorry, not set, so survey set. So we have population weight. So population weight in this case, there is this we call fixed weight. You can be able to see here. So I'll have to copy this and put it here like that. Then strata. So I'll be able to say stratum, wherever we have stratum or strata, we use that variable. So in this case, we are going to use this like that. Control V to close. Then we have primary sample unit BSU. In this case, we have it here. So scrambled health unit identifier. This was the one that was used to represent the primary sample unit. So I copy this, and you can check this from the code book. It has clearly indicated that like that. Then single unit. This is optional, but it's good to include it. Single unit like that. We put it centered like that, centered. So then execute strata, no. strata, yeah. So now we have that. So we have successfully done what we call surveyed sign set, and the data is now nationally represented. So for instance, if I can just do let us say the mean of age. So I can just say the mean. So since it's a survey, I need to use this survey. For instance, CVY like that. Then mean of age. So we have age in this case, remember, which is actually a numeric. So do that and execute. Perfect. So you can see the output now. You can see the output. The mean age is 57.13. Then the population size, you can be able to see number of strata 5, number of BSU 10, the number of 611. Then the population size now equivalent to 191,820 patient fees approximately. So this now, like the analysis now will be based on this sample size. Sorry, the population size, but not the sample size or the number of observation, which is 619. Yeah, so up to that point, this is what I wanted us to have, and that's how you use ICD-10-CM codes in this National Ambulatory Medical Care Survey to identify comorbidity conditions in STATA. So let me know in the comments that what conditions you like to extract next, or if you like video, you like a video on using Charlson comorbidity index, you can also tell me. Please don't forget to like, subscribe, and hit the bell for more healthy data tutorials. See you in the next video.